Okay, what we're going to do in this video is have a look through this worksheet here. So this is wave problems 12 to 15. We'll go through the answers to these. So the first one looks at this weather station, and you've got waves that are 9.2 meters long, and you've got various information about it, and you have to determine the speed and the frequency of these waves. So what we'll do to start with is think about what we know already. So we know that the waves travel 50 meters and it takes them 21.8 seconds. So that tells us the first thing we can actually calculate is the speed. Okay, so we're going to calculate the speed of the waves. And we use, so this is 12, we use this formula here. Speed is distance over time. So it's 50 divided by 21.8, and that gives us a value 2.294 meters per second. Okay, so we've got the first part. Then what we need to do is calculate the frequency of the wave. Now we know already, we know the speed of the wave, and actually from the information here, we know there 9.2 is the wavelength. Okay, so if we know that V is f lambda, then we can calculate f equals v over lambda. So that's 2.294 all over 9.28. Put that into a calculator and it will give you 0.25 hertz, and that's rounded to 2 decimal places, and there's your answer. Okay, so that's number 12. 13 gets you looking at this problem around humpback whales and their frequencies. So they range from 20 hertz to 10 kilohertz, or 10,000 hertz. And we also know that they travel at approximately 1400 meters a second. So we need to determine the wavelengths of the waves at the higher and the upper ends of this frequency range. So to do this, so question 13, we are going to again use the formula V equals f lambda. And for the first one, so if we do the higher, we'll do the higher range, then we know that the frequency is equal to, so we know the frequency, we want to know the wavelength, and that is equal to V over f. So the velocity of the wave is 1400, and the frequency in this case in the upper range is 10,000, and if we put that into a calculator, that gives us 0.14 meters. So that's our first answer. And then the lower range, again we use this same formula here, and that gives us, again the velocity hasn't changed, and we just divide that by 20, that's 20 hertz, and that gives us a value of 70 meters. And there are our two answers for that question. Problem 14. Now problem 14 uses this wave on a string essentially, and it asks you to calculate here the kind of wavelength, also state in degrees and radians. Okay. Now what I'm going to do on this one, so C to E, so C is here and E is here, and what we can see is that that is a full wavelength. So C to E is 1 lambda. Okay, so 1 lambda, and we know that 1 lambda is equal to 360 degrees, and we also know that that is equal to 2 pi. So then we've got an answer in lambda, degrees and radians. What we're going to do on the next one, I'll just do this on the next sheet. So this is 14b, so this is C to K. Okay, so C is here and K is here, so we're going a bit further down the string. Again, what we do is we make sure we count the number of waves. So there's 1, 2, 3 and half a wave. So we know that that is 3.5 lambda. Now what we would then do is you do 3.5 times 360, and that will tell you the degrees. So that's 260 degrees. And we also know that 2 pi is one wavelength. So if we do 2 times 3.7, 3.5, sorry, that gives us 7 pi. So we have our answer for that one. C, A to J. So A is here and J is here. So we're actually returning to the same point on the wave. So we should be able to count full wavelengths. So 1, 2, 3, 4 wavelengths from A to J. A to J, so that is 4 lambda. Again, 4 times 360 gives us 1440 degrees. And 4 times 2 pi is going to be 8 pi. So there's our answer to that one. D gets us looking at B to F. So B is down here and F is up here. So we're definitely going to be doing half a wavelength because you're going from a trough to a crest. So that's 1 and a half. So see that again, 1 and a half. So that is B to F is 1.5 lambda, which we know to be so that's going to be 360 plus half a wave, which is 180. It's 540 degrees, and we know that one wavelength is 2 pi and half wavelength is pi. So 2 pi plus pi is 3 pi, and there's our answer there in radians. E is D to H. So D to H, this looks awkward, but actually the dot returns to its original place. So all we need to do is go, there's one wavelength, and then it goes, essentially, let's just double check this, so it goes 1, 2, that's actually 2 wavelengths. So it looks tricky, but all you're trying to do is work out, so you're returning to a point there, and then it returns to the same point again. So that's D to H, 2 lambda, 2 times 360 to get the answer here, so that's going to be 720 degrees, and then 2 times 2 pi is 4 pi, and that's our answer there. And then we have F, and F is E and I. So E, again, this E's here and I's down here. So this is a bit of an awkward one because we're going to go 1 and then 3/4. So we can write this, so E to I is 1 3/4 or 175 or 0.75 lambda. Then that makes 630.
Talking to yourself, love.
Recording. Cheers. So 630 degrees, and then if we're going to work out this in radians, we know that essentially we need to do 1.75 times 2. No, it's got. There we go. So on this one we got 1 pi, 2 pi, 3 pi, and then a half down to there to I. So it's essentially not. We can't write 3.5 pi, so we'd need to write 7 pi over 2. Okay, and then we just come to the last question. That's the last question, number 15. This is quite a tricky question. So what I've done with this question is I write down the things I know. So I know the period is going to be 6.6 seconds. And the other thing I will do is, in this case for 15, is I draw an image. So we have a pier here, and the pier, it says, is at the top of its cycle when the other is at the bottom. So if we draw the other pier down here, and what we need to know is also there is a crest between these two, a full crest of wave. So the wave actually does this and drops back down to that second pier. So there's a second pier there. So we actually end up with a wave pattern that looks like this, okay? And what we know is that this distance from here to here is 24 meters. So we can actually, from this, calculate some key things. So we know that this is going to be 1.5 wavelengths from pier to pier. Now that's 3 pi. So 3 pi is 24 meters. Now what we want to know is we want to know one wavelength, or we want to know 2 pi. So what I do, if we do 24 divided by 3 and then times it by 2, that allows us to convert 24 into 2 pi. Okay, and now that gives us 16 meters. So that wavelength from here to here is 16 meters. Okay, and we know the period, which is t, is 6.6 seconds. Okay, it tells you that because one complete cycle takes 6.6 seconds. It tells you that. So the frequency is 1 over t, which is 1 over 6.6, which is 0.152 hertz, and then v equals f lambda. So we plug in that number, 0.152, times it by 16, which is the wavelength, and that gives us, just down here, 2.432 meters, and there is our answer. That's a tricky question. If you get stuck with that one, give me a shout, or if you get stuck with any of these questions, give me a shout. Okay, thank you very much.